let's go and turn the camera on and see how much smoke comes out. Now this is the Marconi Mk3 image Orthicon camera, which we've spoken about before, and we are now in the process of running it up in preparation for the BVWS Retrotech show later this month. So with these things, it's often best to run them up gently on a variac. This is valve equipment, and part of the process is to let it cook for a bit at, say, half mains, and this runs the transformers and the heaters, and it draws current and sort of gets the dampness out of it. So here is the variac. Turning it on and on again, and you'll now hear a faint buzz. That's the contactor in the power supply thinking about pulling in. And as I increase the voltage from the 50 volts it is at the moment up towards 100, it's really thinking about pulling in now. And there it's pulled in, and we're at 140 volts AC, and we're drawing just a shade under 2 amps. Now, I went through this process yesterday and cooked it for a bit, and I'm confident now to proceed to the next stage and wind up the AC mains input voltage somewhat. Now down here this rather nice meter which plugs into the front of the CCU, and what it measures can be selected with this switch here, and currently it's looking at the HT voltage, and you can see it's slowly starting to creep up as the rectifiers warm up, and that'll settle at about 100 odd volts. It's on a ×2 range, so that it's 0 to 150 ×2. Pop that down there. A bit more mains. Oh, I nearly forgot, and we need to go up here to do that, and that turns the SPG on, which is part of the fixed installation for the purposes of this testing. The camera wouldn't work very well without the SPG. So we're now at about 200 volts AC in, and you'll see that the meter here is more or less up to its correct position. The power supply here, which is full of valves, makes 250 volts DC stabilised at 1 amp. And if you poke the camera in there, you can see them glowing nicely, and the 2 reference tubes there. Those 2 resistors there are in series with the anodes to help share slightly the current between the each half of the valve, and you'll see that each valve has got a set of 2 resistors, and there are 6 rectifier valves, each being a double valve in parallel. Now those resistors, these green resistors, they're wire wound resistors, and they do have a habit of going open circuit, especially at 75 years. So I'm going to turn my camera on and look at them with an infrared scanner, and we'll see. I mean, I could stick my finger on and see if they're hot, 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 cold. They're all hot, which means they're not open circuit, so that's fine. And we have a bit of a trace on the raster on the monitor. It's not locked, but then it is at sort of half, well, not half, 2/3, 3/4 mains. It'll settle down, especially when I increase the voltage. And here is the waveform monitor, also not locked. And if we go round here, I've got a raster in the viewfinder. The viewers of this interesting and exciting programme will have to excuse the duff camera angles and all sorts of things, because it's a bit crowded in here, to say the least. This was one of the things that wasn't working at an earlier stage. It had frame scan collapse, so I poked around a lot in the back there, as you do, and eventually discovered that frame drive was missing. Frame drive, follow me. Frame drive comes out of the CCU, so the next step was to go on here with the scope and discover that frame drive was present at that point. That's looking at the incoming sinks from the SPG. So there's a certain amount of poking around, and on here there's a amplifier for the frame drive system, and that fella there, R84, isn't really a resistor, it's more of an open circuit, but a replacement which I soldered in yesterday cured the problem. If we look round at the monitor there, you see that the raster has sort of settled down and the viewfinder has sort of settled, the waveform monitor has sort of settled down, and I have got some control. I'm adjusting the black level control there, and you can see that there is an effect which is encouraging. The other one is that one. This is the line shading control, which puts a sawtooth on when the tube's off. You'd normally use it to correct any shading, but it does at least prove that part of the video amplifier is working. So we're going to put the CCU back, pop that dead resistor on there, and I'm going to pull the waveform monitor out. I'm supposed to be on light duties, by the way. Come on out, you bugger.
Do the editing.
Now, this waveform, picture and waveform monitor, has got a separate EHT circuit on a oscillator and power output valve. It's not driven from the line scan circuit, as is the case with televisions, and this enables the EHT generator to be stabilized so that your picture size doesn't change with picture content. There, that thing, which I'm keeping my finger at least an inch away from it, is the EHT rectifier, and that was faulty. I think it had gone down to air, and here is the offending article. It's a U41 or a 1B3 GT. U41's easier to remember, and annoyingly, because it's failed, it's marked with the Marconi wireless and telegraph logo, and there's its I put a cross on it so it doesn't cause me grief in the future, and that had gone down to air. Unfortunately, the spares department yielded up another one which I plugged in, and it worked just like that. So that's 2 down and an uncertain number of faults yet to be found. I can go back. I'm going back to the power supply. We've currently got 200 volts AC going in, and I'm going to creep it up another notch now. And that's 220, and interestingly the current now that it's drawing has crept up to 5 amps, which is a tad higher than I'd hoped for. I would have been happy if it was settling at 4. So I rather think that there's this, that and the other in the circuitry is drawing a bit too much current. If I go up to 240, the current creeps up again to almost 6 amps. So I'm going to go back to 220. Another thing worth looking at is while we have the camera, if you go in on the front of the power supply, on the meter there, you'll see there's a green patch. Just reduced, and you see that green patch is the set point to indicate the correct voltage input, and slightly below the meter to the right there's a pointy knob which changes the primary taps on the mains transformer, so that in an outside broadcast situation you can adjust your rather uncertain mains voltage to give the needle in the green to indicate the correct supply. Also of note, I'll tell you a little story here. If we have a look at the waveform monitor here, you can see that our sawtooth, which was previously poking out above black level, is now sort of crushed into black level, and I'll adjust it like that. This is because the mains voltage has changed, and the story is, a few years ago when I was running this camera up, I had enormous problems with the black level drifting up and down. Normally you dive into the clamp circuit in the video amplifier and change the coupling capacitors that puts the positive and negative pulses into the clamp diodes. So I did that and it didn't help. So I stared at it for a long time and that didn't help either. So there was much head scratching, and then I noticed that the video waveform on the monitor was hummy, and I thought, that's odd. So I started to look at why the rectified DC was hummy on the, showing on the brightness on the monitor, and that led me to the mains input voltage. This is our mains here at home is normally a solid 240. Well, it was coming in at 190, and I thought, that's unusual. So I watched it, and as the black level waved up and down, so did the mains input volts. So I went off and rang up the electricity board. It's very difficult to get to a human being who understands the concept of varying voltage. Eventually I did, and I got them to confess that the local substation was bust, and it was coming down rather a long piece of wire from the adjacent substation. But that in itself, getting them to agree that it was faulty and ultimately to replace the substation, took a lot of doing. But it did fix the black level problem. What should we talk about next?
So can we get any pictures out of it?
That's a bit early yet.
A bit early for that.
Well,
okay.
I haven't done that.
Oh right, okay. The sawtooth is coming from the through the camera, is it?
It's coming. It goes in at the CCU some point.
Okay, so it's not coming from the camera
Well,
channel.
there is a test point on the back of the camera video amplifier here,
Yeah.
and I was contemplating putting a test signal into that.
You've got to supply this generation of camera. You've got to supply your own test signal to the camera. Right.
Yes.
Okay. All right. Well, it's up to you, Brian.
Or I could just try turning the tube on.
Ooh. Okay.
Ooh. Well, I'm a little bit relieved here. You'll see there's a little poxy little neon there, which is lit. And when you read the words, it says scan on.
Oh, right. Okay.
The camera has protection circuits that detect failure of either the horizontal or vertical scan for the tube. And if either are low or missing, it will turn the tube off and that light goes out. So the tube's being scanned. We could turn the beam up and see what happens. Are we brave enough?
Yes.
Yes! Right, let's swap places. So, back to the CCU. The first thing I'm going to do is turn the line shading, and I think I'm just going to have a tad more mains volts. Watch up.
More volts, Igor.
More volts. There's an interesting coggle there. I don't know how well the camera is showing the waveform. There, is that showing up?
Yeah.
Yeah, so there's a coggle at the start, but we'll worry about that later. And it's also a bit sort of flashing and banging up and down. So the most important thing is to put the target sort of 40% up. The image focus leave alone as with the multi-focus, and also the alignment controls here, because this camera has worked in the past. I have not adjusted those controls, and if they were seriously maladjusted it can make getting a picture out of it in the first place quite tricky, especially the alignment controls, because the beam has to go down the middle of the tube, and if they are seriously maladjusted the beam will go off to one side and never make it to the target. So was the beam current, that one. So if I advance this, oh, I like that. Did you look at the, yeah?
There's a sort of a spot there.
Yeah, that's coming off the tube.
Okay.
I can't say I like, it's good to see something, but I'm not sure I like the look of it much. All this noise here is an indication that there's something happening, but I don't like that spot in the middle. I don't like that at all.
That'd be a fault on the tube.
Who knows at this stage?
Okay, so
I know what the problem is.
missing voltage somewhere.
Yes, or more correctly, missing current. Another sidetrack story. When the Marconi Mk3 was originally built, it was available with a 3-inch image Orthicon tube. So this required a focus current of some 75 MA. When the 4.5-inch tube became available, and most cameras were retrofitted to take this tube, that tube required a focus current of 140 MA. The standard power supply wasn't up to this, so Marconi produced an additional power supply for the focus current. These are quite rare. I haven't got one, so I actually had to make it, and I'm sure I spoke about this the last time. So there is the focus current switched off. Switching it on may change things a bit. So that's valves, and it'll take a few moments to warm up. Yeah, the current meter's starting to shoot up to some hopefully right value. Do you want to change places and look at the meter? So here is the current meter, and there's a knob to adjust it. What the adjustment does, it effectively changes the focus of the beam onto the target, and there's a good spot for it, and if you adjust it quite a lot you can go through various focus modes, and there's one focus mode which will be more beneficial to the general geometry of the tube than the others. So now we've got some focus current into it, let's turn the beam current back up and see what we've got. Did you see that blip there? I'll do that again from flat. Watch the raster. Apart from all the flashing and banging. There, that's a bright up. That's the initial discharge of the target, and there is some noise now, and if I give it a bit more there's a lot of noise. So that's a good spot about there. And we're now going to look at the optical path onto the tube target and see if any light is actually getting in there. not got anything on the viewfinder. That's position 1. Looking at the open the iris on the lens. Ah, there. Wave in front of lens. It's not much of a picture really, but the point is that light going in is producing an output.
Yes, just about see your hand.
Yeah, let's try wanging the focus round to see if that helps at all. Interestingly, there's no picture on the viewfinder. Is it doing anything?
Possibly. It's difficult to say.
Yeah.
Yes. Look, I can see the rack.
Yes.
Behind.
Ah, up in that corner.
Yes, there's something there, but only if I put my hand.
What I'm going to do is I'm going to put that lens back on there, which is a wide angle lens, and they're always a good thing to start with because setting the iris.
Okay, it's out of focus, but there's something there.
But we have got a picture.
We got something. That's not bad for a few minutes' work, is it? And this is what, 70 years old, this camera? Or more than that?
50, 60, 70. It's a good 70 years
70
old.
years old. Well, there you go.
Well, probably 70. Let's round it up to 3/4 of a century.
Yeah, okay.
Just looking at the picture monitor, I've turned the beam down, and as I turn it up you'll see the flash as it discharges. Right, there's the picture, and the thing is critical. If you give it too much beam you get lots of aliases and distortions, but there is a sweet spot. Did you see it there? Just as an addendum to looking at the front of the CCU with its adequate supply of knobs, there are other adjustments scattered around. There are 3 here, helpfully marked focus mod, image accelerator and decelerator, and they're 3 that require adjustment but less frequently, so they're set up and hopefully don't require further adjustment. But the whole thing is hands-on. This is well before the idea of an automatic camera was even on the horizon, so in operation it required the constant adjustment of a skilled vision control engineer.
Times the number of cameras in the studio.
Well, at this point it was 1 engineer per camera. When I started work it was 1 engineer per 2 camera, and after a while it went to 1 engineer for 4 cameras, and that was quite hard work getting all 4 of them happy. Then it went to 5 cameras per vision control engineer, and that didn't work because you couldn't get your hands around them.
And now the question is, what's an engineer?
Indeed. I'm actually quite pleased with that at this stage.
Absolutely. Oh, it's settled down now again. It's the
Well, the thing is full of components that are waiting their turn to fail.
Exactly.
A little bit of line shading, field shading.
And so this is 625, isn't it?
We're on 625. The intention is to run it on 405, but all the monitoring here works on 625, so
that's a better place to start.
it's a better place to start. going 625 to 405 is just a case of changing a few links in the scanning circuitry, and shouldn't be too difficult. I can see the image focus there is going through a node. This is the main. This control is the beam focus. Do you remember I said that the current in the focus coil affects the focal point? Well, this is the voltage in the tube wall anode that also affects the focus, and you can see that it's circulating round in a motion like that as it goes through various nodes. So that's a focus point. Round again, and there's another focus point there, and I think that one's a little bit better than the previous one, and that's almost at a third one. All I can say to our illustrious and highly appreciated viewers is that we will make it a lot better than this. The thing is, even at this age, capable of good sharp pictures, and we'll get there. I think I want an insulated poking stick.
Okay, which is always a good thing to have.